Hello guys, welcome to another section of our studies on differentiation. We are mastering the quotient rule of differentiation, and this rule is used to differentiate functions in the form of fraction. Now, let's understand the quotient rule, its definition and formula. The quotient rule states that if y is equal to u divided by v, where both u and v are functions of x, then the derivative is given by, we have dy dx. It means we are going to differentiate y with respect to x. Since u and v are both functions of x, is equal to v times du dx, where v is the denominator here, minus u, which is the numerator, times dv over dx, all divided by the v square. So in simple words, what it means is that denominator, which is the bottom, times the derivative of the top, which is the numerator. So v times the derivative of the top, which is du over dx, minus the top, which is u, times the derivative of the bottom, which is dv dx, all over the bottom square, which is the v square. So that is what the rule says about the quotient rule. So here, if we come to real life example, if fuel price E is calculated as distance divided by fuel used, which is F, and both D and F changes with respect to time, as shown below in the expression. So we have E equal to D of T over F of T. They are distance that change with time and fuel use that also changes with time. So we are supposed to find the fuel efficiency. The quotient rule can help us to find how efficiency changes over time in this particular example. So now let's go to quotient rule and some examples. Definition, we have to differentiate y being equal to x squared plus 1 divided by x minus 1. So we are aiming to find the derivative of this particular function. The numerator is a function in x, and the denominator is also a function in x. What will be the solution for this problem? We have to let u be the numerator, which is x squared plus 1. So du divided by dx is equal to 2x. Then v also equal to the denominator, which is x minus 1. So when you differentiate the v with respect to x, we are going to get 1 because the constant will be 0. So here we quote the formula for the quotient rule, which is dy dx equal to v first times du dx minus u second times dv dx, all divided by the denominator, which is the v squared. So we substitute each of the labelings at their respective position in the function. So u, which is x minus 1, is here. Then du dx, which is the 2x, will be substituted as this format. So minus the v, u, that is the x squared plus 1, times dv dx, all divided by the v square, which is x minus 1 squared. Then we expand and simplify the numerator. We expand and simplify the numerator. So the numerator will be 2x squared minus 2x minus x squared plus 1. So you expand the top and simplify the expression. And the expression now will become x squared minus 2x minus 1. So that becomes the simplification expression for the numerator. Then you substitute this into the formula now, we have x squared minus 2x minus 1 all divided by x minus 1 squared. So that is how we use the quotient rule. Now let's move to the example 2 of this particular section. We have to differentiate y equal to square root of x plus 2 all divided by x squared. So in this section, we are supposed to let u be equal to square root of x plus 2. And we have to also find the derivative of the u with respect to x, and that will be du divided by x equal to 1 over 2 root x. So when you differentiate root x, this will be your results because the constant will be 0. Then we also have to let v be equal to x squared. That is the denominator. And when you differentiate v with respect to x, we are going to get the change in v divided by change in x equal to 2x. So we are to quote our quotient rule, which is dy dx equal to v times du dx minus u times dv over dx, all divided by v squared. So the denominator, differentiate derivative of the numerator minus the numerator times the derivative of the denominator, all divided by the denominator square. Then we substitute these variables, the expression that represent them at their respective position in the function. So v is x squared, here is it. Du dx is 1 over 2 root x, and here is it. So we have a multiplication of these two particular expressions. Then minus the u, which is root x plus 2, times the dividend here, which is 2x, then the v, which is x squared, all squared. We have to write the numerator and simplify this numerator. So expand and simplify this numerator. When you do that, we are going to end up with dy dx equal to minus 3 on 2, minus 3 x raised to the power 3 over 2 all over 2, like this, minus 4x all divided by x raised to the power 4. Why? Because 2 times 2 will give us 4. And this will give us dy dx equal to minus 3 on 2 x raised to the power minus 5 over 2 minus 4x power minus 3. So everything here will be simplified as dy dx equal to minus 3 divided by 2 root x raised to the power 5 minus 4 divided by x power 3. So that is how we use the quotient rule to differentiate this particular function. So remember, know how to turn this kind of expression into a root form. Know how to do it. We got x minus 5 on 2 will be in the form of reciprocation, that is inverse, where it will tend to be a denominator, which will be 5 divided by 2. That is, the negative will be off and become positive. The 1 over 2 is the same as square root. So this expression means that x power 5 times 1 over 2. That is the reason why our final answer is of this form. Don't forget to try your hands on this particular questions, then send your feedback to us for us to go through it for you. So we are looking forward for the next section or the next rule of this particular studies. Thank you.